Hi, my name is Marton Balázs, the sail designer of 1D Sails. Today I will show you how we do the sail development process for the F18 class. The first point is to find the sail shape and the perimeter of the sail. For the design process, we use different kind of softwares. We have the Smart Azure one, which is a really amazing sail design and analysis software, and we have our in-house modeling system. In the in-house part, we can analyze the load distribution and the perimeters of the sail. We have a velocity prediction, so we can test the F18 virtually from very early stages. We use CFD, so computational fluid design softwares for virtual analysis, and we use Embark, which is a numerical modeling for sail performance. We are working with given rig dimensions as we are talking about F18. We have an inner loop which is between the Smart Azure and the virtual analysis. And we have the outer loop which shows the whole process of the development. So after the design part, it goes into proto-production, proto-testing, proto-modification if needed, and we start the loop from the beginning again. In Smart Azure, we use the aero analysis module, where we have the given sail shape, what we have created before, and we can input different details of the wind conditions like speed, angles, sheeting angles, heeling angles of the boat, and we can get really interesting data like pressure coefficient, side coefficient, drive, lift, drag, all these fancy things that we use to analyze the sail shape. After the aero analysis, we go to the structural analysis, where we can see how the sail will be distorted. Here, we can give the sail material that we use. We can give many ones as we prefer. And we use the results from the aero analysis. We can set up all the different perimeters, how we want to work. From this, we can get many interesting results as well and data. One that is really important for us is the mesh differences. So how the sail shape will react to the load of the sail. So we can see the deformed mesh is the green one, and the original mesh or original sail shape is the red one. We also can have different loads at the end and angles, and with different other things like how the sail wrinkles, the corner tensions, total displacements. So many really small, important, and interesting parts. But there is one really important point with Smart Azure. It is not a CFD software, so the flow is laminar. And the other important point is we cannot look for the end plate effect. So the solution is the CFD analysis. Here we can look for much more details. We define 6 apparent wind angles, 3 upwinds and 3 downwinds. We define 10 apparent wind speed, 5 upwind and 5 downwinds, and 3 to 5 trims for each set. We are defining 12 different flying shapes per sail, so we can compare all the cases, and this is how we can get the more wind range to the sail. The data that are coming out from the CFD are going into a spreadsheet for analyzing. We have some really nice post-processing of the CFD, and here you can see how the end plate effect is working or even not working. What is the situation with the snuffer bag? We use different kind of CFD softwares for different kind of applications. Analyzing the numbers. We have a spreadsheet with different graphs and different numbers. So we analyze the cell shapes here. Science behind the cell. So let's see the positive and the downsides of this kind of development. So first, it's much more reliable as we use facts to decide where to go. Much more precise data management. Less cell production, so it is much more environment friendly. And better comparison between different cells. So it means we see clearer which cell performs better between 2, 3, or 4 sets without building any of them. The downsides, it's knowledge needed. You have to know how to do it. You have to know how to analyze the data you get. The other big issue is the cost, the softwares and the hardwares as well. So it's pretty costly thing. And the work can be demanding. Of course, we prove it by C trials after we found something really exciting virtually. And we test them with pro teams. And the biggest test and the proof of the cell, always the World Championships. So it shows where to go and what to do next.